Yep. Alright, so let's start off with our first order linear equations. I've got my textbook next to me on the other screen, so I'm just going to be doing them from there. Whichever ones like have already solved answers. Just integrate both sides. Alright. That one was done, so that one was number 1. Now we're on number 2. Dx plus 3x dy equals 0. Subtract, see, what do we want? We want to isolate the dy. Well, separate, yeah. We have e to the 3x dy equals negative dx. So now we have dy equals negative e to the negative 3x dx. Integrate both sides and we get y equals 1/3 the 3x plus c. Both of those were correct. I was wrong on the first one, actually. It was negative, because integral of negative sign is of sign is negative. Yeah. All right. Next is x dy dx. Yeah, I'm definitely gonna do different ones, but I'm just warming up right now. So divide both sides by y and divide by x, or xy, and we get, what was that? Okay, we get 1 over y dy dx. I'm gonna move the dx to this side, equals 4 over x dx. Is that right? Yeah. Integrate both sides and we get ln y equals 4 ln x plus c. So first thing we can do is move this into here and make that x to the 4th, and then we can do e to this power, and then we do y gets equals e to the x to the, or e to the ln x to the 4th plus c, right? This becomes e to the c is just another constant. E to the ln x to the 4 is just x to the 4. So y equals cx to the 4. And that is correct. Alright, let's do some more interesting ones, and then we'll move on from the separable. Not 9. That's the problem in the bit. So, it was that one. So this is number 4. Y ln x dx dy equals y plus 1 all over x squared. Alright, so this one should be interesting. So multiply both sides by x squared over y. Right? So multiplying that, then we get that this side is x squared ln x, oh, and dy. X squared ln x dx equals, the x squared will cancel, and we have y squared plus 2y plus 1 over y dy. Certain things will cancel, but this is just going to become y plus 2 plus 1 over y dy. Integrate both sides. So this right here, we're gonna have to use integration by parts, equals x, ln x equals 1 over x, dp equals x squared, 1 over 2 or 3. We got 1/3 x cubed ln x minus integral of 1/3 x squared dx equals 1/3 x cubed ln x minus 1/9 x squared, or x cubed, equals 1/3 x cubed times ln x minus 1/3. So now we plug that into that equation and we get, integrate this side also, we get 1/3 x cubed equals 1/2 y squared plus 2y plus ln y plus c. So I'm pretty sure there isn't really a explicit way of expressing this. I think this is like the best we're gonna get. So yeah, we have our answer 1/2 y squared plus 2y ln y equals 1/3 x cubed ln x minus 1/3 plus c. Let's see if that's right. Yep. Hello. So now I think we're good on separable. That was just our warm-up. All right. Now we have some linear equations. dy dx plus y equals to 3x. I'm not sure if we're supposed to use integrating factor or not, but that is basically trying to do product rules. So you do e to the integral of that, which is just e to the x. So this is just going to be e to the x times y, differential of that equals e to the 3x. Integrate both sides, we get e to the xy equals 1/3 e 3x plus c. Y equals 1/3 e to the 2x plus c to the minus x. Is that right? Okay, and then I also have to determine the interval that it works on. Since there are no discontinuities, the solution is valid for that interval. And this term, since the limit as x approaches infinity of c to the minus x equals 0, that is transient. Alright. Yeah, once we start getting to the harder stuff, that's when it's going to get a bit more interesting. So this one's x squared y prime plus xy equals 1. We could use integrating factors, but I can just do sort of by guessing. If there was a 1/2 here, well, yeah, I guess, yeah, 1/2. Multiply everything by 1/2, and you'd get the answer, right? Oh, yeah, this is d of 1/2 x squared y equals dx. Integrate both sides, and we get 1/2. So this one is going to have some discontinuities. What is it? It's going to be 2x to the minus 1 plus c x to the minus 2. I guess 2c. But so both terms are transient, and since it's discontinuous at x equals 0, the largest interval of convergence is from 0 to infinity. Let's see if that's correct. That wasn't the one I clicked. Solution is transient. Okay, that's what you could say. And I got it wrong. What did I miss? Oh, I didn't multiply this by 1/2. That's one thing. But there's an ln x there, so that's meaning that there was supposed to be something else. I think I know what it's saying. But let's just redo the problem. So I did it the guess way, but the actual way you're supposed to do this is divide everything by y prime, you get 1 over x. Y equals 1 over x squared. Not integrate. Multiply by the mu of x equals just x. Or, yeah. Because it's e to the integral of this, right? And the integral of that's ln x, so it's just e to the x. Or just x, yeah. But that's where the ln x comes from, is when we are. Oh, it's not y prime, it's just y. xy equals ln x plus c. Y equals x minus 1 ln x plus c x to the minus 1. The whole thing is transient and largest interval. So solution is transient. And also Largest interval is from x equals. That's the largest interval. Seven. X times x plus 2, y equals e to the x. I divide everything by x squared. We got y prime plus, this will be 1 plus 2 over x squared. No. 1 plus 2 over x times y equals the x, or okay, if this is going how I think it's gonna go, then it's not gonna go well. But I think this will be fine. So this becomes d of integral of e to the integral of that. Oh no, yeah, that's right. We just multiply everything by e to the integral of 1 plus 2 over x dx equals e to the x times e to the ln x squared equals x squared e to the x. So multiply everything by that, we get d of y times, what is that, x squared e to the x. The x squared and 1 over x squared cancel. This is just e to the 2x dx. Integrate both sides. Get y, or x squared e to the x, y equals 1/2 e to the 2x plus c. Y equals, there's going to be discontinuities at 0, and the whole thing is going to be transient. 1/2 x to the minus 2 e to the x plus c e to the minus x to the minus 2. This whole thing transient, and then the largest interval is from x 0 to infinity because there's discontinuity at 0. And is that correct? Yep, it's just correct. Alright, I think we can move on from this kind of linear equation. Maybe we can go down to yeah. Oh, we haven't done many initial value problems, but I'm just saying if there's an initial value problem, I'm using Laplace transforms. Who cares about, oh, never mind, that looks pretty nasty. I wouldn't want to take the Laplace of that. What is that? X cubed e to the x squared. Nah, no Laplace transform of that. Not visible? Oh, hello. Yeah, I'm right here. Hello. I could be like looking down most of the time though, that's the thing. And then y of y of 0 equals -1. I mean, if I did take Laplace transform, what would that be? S y of s minus y of 0 or plus 1 plus oh, don't know how to take the Laplace of product like that. I think though, no. What is it? You know what? Yeah, it's gonna be easier to just do the integrating factors. So multiply everything by e to the integral of 4x dx, which equals e to the 2x squared. Now we have e to the 2x squared y differential of that equals. Is that sure it's not negative? Okay, whatever. This is gonna become x cubed e to the 3x squared. Oh, okay, no, that's easy to integrate. That's just e to the x cubed. No. If it was the other way around, the e to the x cubed, yeah, okay. That is super annoying. Well, it's no biggie. Let's do integration by parts. So we have equals x equal dx dv equals let's do x squared. This is 2x e to the 3x squared. Integrating that, we get 1/2 what is that? That's gonna be 1/2 or 1/6. Yeah, 1/6 e to the 3x squared. Then we do multiplication, we get 1/6 squared x squared minus the integral of 1/6 times 2x, 3x e to the 3x squared. Then we can integrate that. That's just multiply by 1/2 or multiply by 2, so this is 1/2 6x, and then this becomes 1/6 x squared to the 3x squared minus 1/2 e to the 3x squared dx plus c equals 1/2 e to the 3x squared times 1/3 x squared minus 1. Solution is transient, and there are no discontinuities, so solution is valid for x numbers. Or interval. Okay. Is there like a really good method at erasing stuff on this? Because currently my best method is just to do all this like it's a whiteboard. Well, it is a whiteboard. I just realized I messed up the entire problem. Okay, if I can remember we had y equals, what was it? We'll be smart. We'll look at, no! Okay, I'm gonna look at 30 seconds ago. It was 1/2 e to the 3x squared. No, it wasn't. That was our, it's y equals 1/2 e to the minus 2x, or x squared, times 1/3 1/3 x squared minus 1 plus c e to the minus 2x squared, and our y of 0 equals -1. So yeah, big smart on me for thinking quickly, but alright, so oh yeah, let's just plug things in. So we have 1 equals 1/2, this becomes 1, that's 0, so 1/2 times -1 plus c times just 1. So we have -1/2, so add 1/2 to both sides. And we have c equals -1/2. So our final answer is 1/2 minus x squared times 1/3. 1 plus. That's our solution. There's no worked solution, but that seems about right. Okay. So I think we're good. I mean, we can try one more. Alright, this is our last one before we go to substitution, or whatever the next section is. Tan x y cos squared x. Now I could try Laplace transforms, but I don't want to because there's a product here and that gets a little messy. So let's just do integrating factors. So e to the integral of tan x dx equals e to the, that's sine over cos, so e to the negative ln cos, or that's ln sec x just equals sec x. So now we multiply everything by that and we get y sec x, differential of that equals sec times cos squared is just going to be cos x dx, integrate both sides, and then we get y sec x equals sine x. So let's see, y equals 1/2 sine 2x plus c cos x. So now we have negative 1 equals 1/2, or y of 0, which is, that part's going to be 0. We have cos 0, which is just 1. So now we have our final answer, y equals. Yeah, so that's our answer. Alright. Moving on to substitution. Alright. Exact equations. So this is where you have the multiple. That's right. So you need partial m partial y equal dm dx. Sort of like Green's theorem, where you had like um, that's right, you have to do the exact same steps. So I'm going to go ahead and do this example one where we do 2xy dx plus x squared minus 1 dy equals 0. Partial this is 2x, partial this is 2x. This is with respect to y, this is with respect to x. So it's good. Next thing we need to do is, this is the since it's conservative, this is the gradient of something, which means this is df dx df dy. So f is going to equal the integral of our x component equals x squared y plus some function of y. Take the partial derivative with respect to y equals x squared plus h prime of y equals x squared minus 1, that's this part. X squared cancel, so h of y equals negative y. So now we have our answer equals our f of xy equals x squared y minus y. So okay. All right. So let's do, and then I don't think it goes to a non-exact made exact. So you have to do like that formula. I kind of want to write that down. Do I have it written down? Well, I need to put in like. Yeah, that's right. Had that. All right. That was a decent example. So it's no, that's not it. It's n x minus n y over m. So we'll have that written down. It's our mu of x equals e to the integral of e to the integral of m y minus n x over n dx, and then and then it's still nx minus my. Alright, so knowing that, let's do 11, or was it 10? I think it's 11. So we have 2y minus 1 over x plus cos 3x dy plus y over x squared minus 4x cubed plus 3y sine 3x, and then this is dx. So differentiate this with respect to y. Get 1 over x squared, 0, and then 3 cos 3x, and then this with respect to x, that's 0. That's 1 over x squared plus, oh, this should be sine. Then that's with respect to y, with respect to x. So this is minus 3 sine 3x. So it's not quite exact. So now we gotta do the integrating stuff. I'm guessing it's gonna be in terms of x, so let's do e to the integral of my. What is m? What is x? Hold up. It's in the form of m m dx. We have m dx plus n dy. So this is our m, this is our n. E my, which is 1 over x squared plus 3 sine 3x minus nx, which is 1 over x squared plus 3 sine 3x all over n, which is just n. Just that. Oh, that's ugly. Did I integrate something wrong? Did I write them down? Why is there a sign there? Fun topics in math. See, number theory is good. After number theory, I mean, you could do logic. So, logic, symbolic logic, set theory. I'm not sure exactly what that would require, but I'm pretty sure as long as you know how to write a proof, which you should be learning in what is it? Okay, so since you're in 8th grade, I remember when I was in 8th grade, I also learned number theory, and afterwards I did. Oh, you could do probability. That's a good one. Yeah, probability is a fun thing to do because there's lots of fun stuff to do with like certain problems, certain fun types of problems. So that's probability would be my next fun thing. You can also maybe try competition math if that's fun. So like things from the AMC and Olympiad. I'm just assuming that like you haven't learned like other stuff yet, and that you're only restricted to like algebra and stuff. So that would be what I'd recommend, is just if you're looking for like a challenge, but that's also fun. So yeah, probability and competition math would be two things. I'm not sure if this would be interesting, but another one you could learn would possibly be abstract algebra. And not really, I wouldn't recommend that, never mind. Because, but yeah, probability, you can definitely do that. I'm trying to think, there's definitely something else that you could do. Maybe it's on Brilliant. Because I'm just thinking, like, you know, you don't have to do calculus. If you do want to do calculus, that's fine. Go ahead. So we got this, they're not the same, so you just can't solve it. That's what am I trying to do? And partial derivatives aren't the same. Yeah, it's not exact. So let's do one that we can actually solve, like this one. I don't know why I spent so much time on that one. Alright, so let's do x and y cubed plus y squared sine x dx. Hey. Okay. So we have this, and then we can do, it's m dx plus n dy. So this is our m, and then this is our negative n. So my equals negative 2y cubed plus 2y's, or negative 3y squared 2y sine x equals, alright, and then nx, or negative nx, is gonna be negative nx well, that's 3y squared, and then that's negative 2y sine x, not, oh yeah, that should be negative, right? So it is exact, check for exactness. Now we got, so f is gonna equal, I'm just skipping a few steps, integral of x minus y cubed plus y squared sine x dx equals 1/2 x squared minus y cubed x plus, or minus y squared. And then this should equal, or no, we differentiate that, so equals, that's 0, that's negative 2y, or 3y, I keep messing that up, 3y squared x minus 2y cos x plus h prime of y. That should equal negative 3y squared x minus 2y cos x. So everything cancels, that means h of y is a constant. So our final answer, f of x, y equals 1/2 x squared minus y cubed x minus y squared cos x plus c. And that is correct. M dx plus n dy. Alright. This one looks fun, and this will probably be the last exact that we solve. Not 15. That's 12. Because we got to move on to other stuff. So this is m n my equals 3y squared x squared, and x equals 3y squared x squared. So check. So let's erase that. Yeah. Now we got so I'm pretty sure that this one, I haven't done it in a while, but I'm pretty sure that that's if I divide everything by 9, so everything by 9, this will be I'm pretty sure it's this, but I'm not 100%. That's well, first off, this will be x squared y cubed, so integrate with that with respect to x, it's a 1/3 x cubed y cubed minus, I think that is gonna be, hold on, what am I doing? I could just do trig sub. So if I was ever unsure, I could just do trig sub. X equals tan 1/3 tan theta dx equals 1/3 secant squared theta. This equals integral of 1/3 secant squared theta over this is, don't worry about all that. Dx is okay, I already got that, and then over 1 plus that cancels tan cube or tan squared theta d theta, that and that cancel. This is 1/3. 1/3 d theta equals 1/3 theta. So, and then theta equals inverse tan 3x. So this is 1/3 inverse tan 3x. Doesn't sound right. I think this is just inverse tan 3x. No, because there needs to be a 3 up here. I'm pretty sure. Hold on, let's just, we have 1/3 theta, right? And then 3x, so tan theta equals 3x, right? Theta inverse tan 3x. So this will equal 1/3 inverse tan. Right. Okay. 1/3 inverse tan 3x is what I'm going with. 1/3 inverse tan 3x plus h of y. Differentiate with respect to y. Equals x cubed y squared. And then 0 plus h prime of y equals x cubed y squared. H of y equals c. Now we have our f of xy equals 1/3 x cubed y squared minus 1/3 arctan 3x plus c. Or I think the better way we're supposed to write our answer is 1/3 arc x squared y squared. Because that's the level set. Alright. Hold on, let me check if that's right. Because I could be wrong with the 1/3. I knew it. There's no 1/3 here. It's because if you substitute the 1/3 tan x, yeah. Arctan 3x. I mean, if I wanted to check derivative arctan 3x equals just 3. Huh, well, there should be a 1/3. Hold up. 1/1 plus 9x squared. Then don't forget the chain rule. Or maybe that is a chain rule. No, there should be a 3 here, so what's up with that? You know what? Don't worry about it. I don't think it matters too much. Oh, and this should be a y cubed. So I need to not make dumb mistakes like that with the integration, so we're going to do another one. We're going to do another one of this type. This one will be the last one though. So let's make it a good one. See, that one looks pretty good. No, this is a pretty good problem. I think this is 13. It's not really solving it, but yes, it does. Oh, it's one of these type of problems. I'm gonna go ahead and do this one. Negative xy sine x plus 2y cos x dx plus 2x cos x dy equals 0. And there they give us our mu of xy equals xy. So multiplying out, we get negative x squared. Well, so when we multiply out, we get negative x squared y squared sine x plus 2xy squared cos x plus 2x squared y cos x. This is all dx. And then this is all dy. All right, so now we do I'm blanking out. We check if it's well, we should know that it's exact because they literally gave it to us. So I'm just gonna assume it's exact. Integrate the x part with respect to x. No, I'm not gonna do that actually. I'm gonna integrate the y part with respect to y because that is gonna be much easier. Because you can do either one, right? You see that here? Which equals x squared y squared cos x plus h of x. Now we differentiate with respect to x. That's going to be 2x. Well, I'm going to factor out the y squared. 2x cos x plus r minus x squared sine x plus h prime of x. And then this should equal, factor out the y squared times 2x cos x minus x squared sine x. Since they cancel, h of x equals c. So our answer is just x squared y squared cos x equals c. Okay. Alright, so Alright, now let's move on to the word problems. Oh wait, no, there's still one more section, the substitution. Oh my goodness, I forgot. Okay, so you've got, if it's a homogeneous equation, yeah. Oh, I forgot about this. And Bernoulli equations. Alright. Okay, so Bernoulli equations aren't too hard, but the homogeneous ones. So I'm gonna work through an example. I guess this could be 14, but it's x squared plus y squared dx plus x squared minus xy dy equals 0. So this is n. So the substitutions are y equals ux, and then our dy equals du x du plus u dx. Substitute that in, squared plus u squared x squared dx plus a, okay, this is going to be x squared minus y, xy, or x squared u dy and then our dy, which is u plus u dx. Alright, so do some expanding. We have x squared times 1 plus u squared dx and then this will be so x cubed and then du and then x squared, and this will be u minus u dx. So some things will cancel out. Let's just factor the things together. X squared plus x squared minus x u squared plus squared u. So now we have, that cancels, we have x squared times 1 plus u dx plus x cubed times 1 minus u du. This is definitely solvable. Divide this by x cubed, 0, and then we have our equation 1 over x dx equals u minus 1 over u plus 1 du. Now we have ln x equals, or go up here, ln x equals there's a way of solving this really easily. Well, we can just do division. But I feel like it's just gonna get us, yeah. No, it's not. We have 1 minus 2 or plus 2 over u squared or u plus 1. If this was minus, yeah, that's minus, so this is 1 minus 2 over u plus 1. U integral of that, which is u minus 2 ln u plus 1. I think combining things might help. U ln u plus 1, 3 minus 2. X equals e to the u times u plus 1 to the minus 2. So now u equals y over x, so we have x equals e to the y over x times y over x plus 1 to the minus 2. Oh, there should be a plus c here. Plus c. C. Okay. Let's see. Oh, they had it the other way. I knew something was off. This is negative. This is positive. So this is actually a negative u. This is plus. So we have ln x equals negative u plus 2 ln, or ln plus 1. You get the minus y over x times y over x plus 1 and c. There we go. Yeah, I need to do more of these type questions. Let me check if they're actually going to be on the final though. Okay, I think I might be wasting a little bit of time doing these. I mean, I think it doesn't hurt because I don't think these are going to be in the final. Who knows? They could be. But, you know, most of the final is going to be like series, Laplace, higher order. They aren't going to test us on systems, thankfully. Bernoulli DE, I like these, so we'll go ahead and do one of these. X dy dx y equals x squared y squared. So the first thing you want is this form. Or no, this is x. So you want to substitute u equals y to the n minus 1. And what is the n? It's whatever power of y this is. So u equals y to the n minus, or 1 minus n. So in this case we have n minus 2, so u equals now we have y equals u to the minus 1. So now we have negative u to the minus 2 du dx plus 1 over x u to the minus 1 equals x, or negative x. No, this was just chicken scratch. Then this is u to the minus 2. So look how genius this is. Can now divide everything by u to the minus 2. And we get, or for x, this is u. I mean, oh, it will make this negative. Equals negative x. Look at that, we can solve that. U, or so e to the integral of that is going to be e to the minus ln x, 1 over x u, yeah, e of that equals negative x dx. Integrate that, we get over x u equals 1/2 x squared plus c. U equals 1/2 x plus, or x cubed plus cx. And then let's just combine that into one fraction. This will be x cubed plus 2cx. So y equals 1 over x cubed plus 2cx, or just cx. That was a Bernoulli equation. So it has been probably an hour and a half since I started streaming, and we've done 15. It's not bad. Oh, okay. I will be right back. I have to take my dog out. Or not my dog, but the family dog. Alright, I'm back. Yeah. Reduction due separation of variables. Oh yeah. Let's do one more of each type of these. Okay, so this is either Bernoulli or substitution. Alright, let's go ahead and do some multiplying. So now we just simplify things. This becomes 1 plus root u over u to 3 halves equals negative 1 over x dx, and then du. Integrate both sides. This is So 1 over u to the 3 halves, or u to the negative 3 halves, is negative 2/3 u to the 5 halves. Wait, no. The 2/5. No, wait. Okay, hold up. Integral of u to the negative 3 halves is negative 2 u to the negative 1/2. Yeah. So we have negative 2u to the negative 1/2 plus 2 root u equals negative, or ln 1 over x. Let's do the plus c on this side. Now we have 1 over x equals e to the 2 root y over x. C times e to the negative 2 over y over x. So yeah, and then we can just do now x equals c e to the e squared, so that's also just c, so the 2's will go away, e to the square root of x over y minus square root of y over x. Any simplifying we can do? I don't think so, but let's see if that's the right answer. Huh. So they're able to describe x, y as a function of x. But basically what I'm gathering is that I was incorrect. I think I know where they got it though. So I think I was on relatively the right track. I understood everything up until the integration. Then I sort of sped things up. Alright, one last Bernoulli question. Hello, people. Go ahead and do a Bernoulli question. This one has an answer, yeah. So now this gives us dy dx plus y xy cubed, or y to the 4. Okay. Now we substitute, I think it's u equals y to the negative 3 du dx negative y to the negative 3, or y, or negative 3 y to the negative negative 2 y equals, oh okay, never mind, I need to do y to the negative 3, and then to find du dx, let's first find y in terms of u equals u to the negative 1/3. So du dx equals, or no, dy dx equals negative 1/3 u to the minus 4/3 du dx. Now we can just substitute negative 1/3 u to the 4/3 du dx plus this will become u to the negative 1/3 equals, x is still there, and then this becomes u to the y to the 4, so raise that to the 4, no. Y to the 4 is u to the 4/3. That's what I needed. Negative 4/3. Now we divide everything and we get our first order equation. Minus 3, this is u to the 1, so just u, equals negative 3x, and then that's cancelled. So our mu of x equals e to the negative 3x. So this is a d of u e to the negative 3x equals so now we have y over x. So now raise both sides to the negative 1/3. We have our answer. 1 over the cube root of 3 halves x squared e to the 3x. I think I could factor out something. We have cube root of 3x times negative 3 halves x squared plus c. So yeah, 1 over e to the x cube root of, I just took out the e to the 3x, and that's now 3 halves x squared plus c. Alright, was that correct? Could have checked. Yeah. Hold up. No, it wasn't correct. So I'll show you where I messed up. I messed up here, and I didn't multiply this. This is negative 3x e to the minus 3x. So to integrate that, so yeah, that's the answer. Explicitly and implicitly, it's equals 1 over the cube root of. My voice is low? Okay. This is about as loud as I can get. How does that sound? Is that really loud? Did I wake anyone up? Good morning. Alright, so we've got I think we're good on Bernoulli. Substitution, I might want to do again, but I don't think that's going to be on the test. I'll have to confirm. Alright, 18. Let's go now to chapter 3. So that was just the first chapter of differential equations. We still got much more to go, so now we just got a couple word problems. These are we'll just do one of these. You know that the rate of something is proportional to the proportional to itself. Then you can do separation of variables. You get 1 over p equals dp equals k dt, ln p equals k plus c, kt plus c. So p equals at a time t, because if you integrate this from 0 to t, p of t e to the kt, and this is actually p0, because that p0 that's how you get the exponential growth equation. Another one is Newton's law of cooling. You have dt, the rate of change in temperature is proportional to the difference between the temperature at a certain time and the ambient temperature. Once again, you do separation of variables. So these rate problems, I think, are going to be the so I think the best place I can look for the type of problems you need to do are going to be the homework. So yeah, I'm gonna go ahead and go to my homework. Past assignments. Oh, gotta sign in. Chapter 3. So yeah, we'll do so these aren't necessarily differential equations, these are just problems. So I couldn't find many problems in the textbook that are going to be like the ones on the test. So this one's pretty easy. We have dp dt equals kp, and p of 3 equals 500, p of 10 equals 4,000. So now we just simply so we're looking for p0. 1 over p That's right, P of t equals. So first we gotta find K and P. So we know that 4,000 equals P0 e to the 10K, and that 500 equals P0 e to the 3K. So what we do, we divide the equations. This will be 8 equals e to the 7K. K equals ln 8 all over 7, or 3 ln 2. And ln 2 is like 0.69, so, or 0.7 roughly. 3 times 7 over 10 over 7. So this is really rough, but uh-oh, what's going on? What does this mean? Okay, never mind. So now we got our K, so now let's just substitute it into the equation. And okay, never mind. Just do the exact value of K times 10. Alright. 205 is correct. So we have a small metal bar whose initial temperature is 10 degrees C. Is dropped into a large container of boiling water. How long will it take for it to reach 70? If it is known that temperature, oh. I actually don't know how to do this. Well, okay, we know that equals K times T minus TA, T ambient, 100.
A small metal bar whose initial temperature was 20 degrees
that hurts my ears.
If we know D is
Yeah,
equal
so I
to
have that. So just solve this. We had equals oh, okay, so we know that T of 0 equals 20. Okay, I can do this from here. T of 0 equals 100 plus C, and we know that that is 10. So C equals negative 90. So T. Now to find K, we need to use the fact that it increased 2 degrees during the first second. So T of 1 equals T of 1 equals 10, no, 2 degrees, and it initially was 10, so 12. So 12 equals 100 minus 90 e to the k.
Greetings chosen, I've been waiting here for you since the beginning of this universe. You know the world is fading. There's a secret power hidden in your soul. Don't be afraid to use
44 over 45. So k equals ln 44. So now that we know that, we can find t of, or not t of something. We're solving for t, and we're looking for how long until it reaches 70.
Infinite power.
So that's negative 30 over negative 90. Alright, that becomes ln 1/3
Infinite power.
So this one I think will be on the test, is this type. Two large containers, A and B. The same sides are filled with different fluids. Oh wait, no, that's not it. Go to this one. A tank contains 200 liters of fluid. Now we're on 19. Yeah, 200 liters of fluid in which 50 grams are dissolved. 200 liters, 50 grams per tank. A. Or just a tank. There's no A and B. Brine containing 1 gram of salt per liter and pumped into the tank at a rate of 5 liters per minute. Then the well mixed solution is pumped out at the same rate. So our dA dt, the rate of change of amount, equals R in minus R out. So that's our overarching equation. dA dt equals R in minus R out. So what is our R in? Well, pumped into the tank 5 liters per minute. So we're trying to find grams. So if we change 1 gram per liter, so if we do times 1 gram over 1 liter, we get 5 grams per minute. So that's how much is going in. So ADT I'm still lost.
A tank contains 200, so we multiply by 4 liters for every 1 minute,
Okay.
and the units of liters 50.
So we got to that. Oh, so I was about to get it. So we're doing amount of salt. So our R out equals our amount. Well, it's being pumped out at the same rate. Our R out is A over. No. Our R out is A over 200. Right? That's the amount of grams. 100 grams per liter. Hilarity. Times our rate, which is the same, which is 4 liters per minute. I'm gonna have to do more of these later, because A over 50 gram per minute. So now we just have our actual rate of 5 minus, this shouldn't be 4, this is a 5. So that should be 200 divided by 5 is like what? 40. Now we have 5 minus A over 40. Sorry, I'm being a little quiet. A over 40. You know, just combine this, we get 200 minus A all over 40 equals dA dt. 1 over 200 minus A dA equals 1 over 40 dt. So A of t, well, not A of t. Still have to do the integration, which is ln 200 minus A equals 40. So, okay, we have that. Integrate that from A0 to A of t, A of 0. So now we have ln 200 minus A, or negative evaluated A of t 0, and this is just t. So we have alright. A of t is on the bottom. So it's going to be 200 minus 50. That's the initial amount of salt over 200 A of 1 over 40 t. So 150 over 200 A of t equals e to the 1 over 40t. I feel like I did something wrong.
A tank minus t over 50.
Okay, let's just solve it with normal. This is going to be negative ln 200 minus a equals 1 over 40 t. 200 minus a equals to the minus 1 over 40 t. Or this should be a c here. So a equals 200 minus c e to the 1 over 40 t. So that's a, and then we just know the initial at t equals 0. We just know that this is 50 equals 200 minus c. So c equals 150. Now we have our a of t equals 200 minus 150 e to the negative 1 over 40 t. Alright. But that key equation right there is what helps you solve these problems, is the dA dt equals Rn minus R out. Alright. Alright, large tank is filled to capacity. Okay, I'm gonna go ahead and return to these word problems later. I'll be sure to do them because I know I need to do them and I know they'll be on the test. But you know, I kind of want to turn off my brain for a little bit while I do the second order stuff, or not second order, higher order. So I don't think there's a reduction of order question, but just in case, go ahead and do one question like it. Pretty sure the negative y1 e to the our integral of e to the negative integral of p of x all over 1 squared. Right? I think that's it. I think reduction order formula. Hey, there's just no negative. Almost had it right. Okay, so our question is let's just do this one. Nine y double prime minus 12y prime plus 4y equals 0. Nah, I don't want to do that. I already know how to solve that. Let's do this one. Squared y double prime minus 7xy prime plus 16y equals 0. So first off, let's just find our change of form, 7 over x y prime plus 16 over x squared y. So this is our p, this is our q. We're also given that y1 equals e x to the 4. So this is a Cauchy-Euler equation that we'll solve later. That's why I don't have to do these reduction of orders, because we already know how to solve these. But you know, it doesn't hurt. y2 equals y1 x to the 4th times the integral of e to the minus integral of p of x, which is this will become positive x to the 7 ln x to the 7 all over x to the 8 equals x to the 4 integral of 1/8 8x to the 7 over x to the 8. y2 equals 1/8 x to the 4th ln x to the 8th. So now our y equals, our solution to the equation is cx to the 4th plus c2 1/8 c2 x to the 4th ln x to the 8th. Oh, let me do it. Erase that, but yeah. That's a Bernoulli equation. We learned to solve that later. But you know, it never hurts, just in case. Just to warm up. Alright, next section. Constant coefficients. This is also pretty easy. So yeah, we'll start with this one. So this will be, instead of r, I use m. Yeah, we have m squared plus 8m plus 16. There's also an e to the m term, but we don't worry about that because that won't be 0. Equals 0. Or I do -4, and then I do like this little 2 here, representing that it happens twice. Then shh. Alright, so now this is just follow the formula. E to the minus 4x c1 plus c2 x e to the minus 4x. Let's try to get like one of each form. So let's see if we can get like a complex one. 22 y double prime minus ky equals 0. So for this one, we do the same substitution, right? And then we get zero, so m equals root k. And we have y equals c1 e to the root kx, c2 e to the minus root kx. But we can rewrite this. So let's think of what cosh and sinh is. Cosh of root k x equals e to the root kx plus e to the minus root kx all over 2. Sinh of root kx equals e to the root kx minus e to the minus root kx all over 2. Is that right? Hold on, I'm gonna have to check that. Yeah, that's correct. So, and then, so if we did multiplied c1 by this by c1 and this by c2, we would get c1 e to the root k x plus c2 or c1 e to the minus root k x plus all over 2 c2 e to the root k x all over 2 let's just do other constants, c3, c4, or k1, not k, I don't know, r1, r2, random letters, and minus, so these would become r's, r, e to the minus root k x all over 2. So we do root k, we factor out e to the root k x all over 2, e to the root kx, right? We have r1 plus r2 all over 2 minus and plus another e to the minus root k x and this would be R1 minus R2 all over 2. This can equal C1. This will equal C2. So now we have C1 cosh so now we have an equation for this. Our solution is y equals C1 cosh root k x C2 sinh root k times x. Alright, I think we'll do a couple more first orders with constant coefficients. Go ahead and do a higher order. That one's kind of boring. So we have m to the fourth plus m cubed plus m squared. We can factor out m squared times, this will be m squared plus m plus 1. So m equals 0 twice, and then it equals negative 1/2 plus minus the square root 3 over 2i. So now this will be our alpha, and then this will be our beta. Now we just plug into the formula. This will now equal C1 e to the 0 is just 1 plus C2 e to the 0 x plus e to the minus 1/2 x times C3 cosine of root 3 over 2 x plus C4 sine of root 3 over 2 x. Yeah, that one is kind of boring, but it's whatever. I would hate to solve these fifth order equations with Laplace transforms. That sounds like absolute pain. Alright, last fifth order, or last higher order. 2 times d fifth x ds. You know what? No, they're trying to screw us up with having s and 5 in the same equation. I'm just gonna have 2 x fifth prime minus 7, and it's x of s. Oh, actually, I don't even want to. I'm gonna let x of s equal y of t. because screw it, you know? This is gonna be 2y minus 7y 4. I mean, if I was on a test, I'd have to make sure I change it back. Y cubed plus 8y double prime. Guess we can write triple prime. So now we have 2m to the 5th minus 7m to the 4th, 12m cubed plus 8m squared. The reason I don't think these problems are super cool is that they're just solving an algebra equation. I mean, that's what we're trying to do half the time, is turn it into an algebra. Turn calculus into algebra, but still it's just kind of boring, you know. But anyways, still gotta do it. Factor out an m squared. Then we have 2m cubed minus 7m squared plus 12m cubed, or m squared, or m plus 8. We'll do factoring by grouping. So we have m times 2m squared minus 7. No, it's not gonna work. 2m cubed, oh yeah. It's factor out of 2m, m squared minus 1. Or m squared plus 6, right? And then minus 7m squared plus 8. I think what we should do is complete the square. So if we can complete the cube basically. My goodness, factoring for this is not nice. If we have like 2m, right, minus or plus, it's just evil. Oh, I know what we can do. 2m cubed plus 8. Nah, I wouldn't want to do. Would I? Well, let's try it. Let's do 2 times m cubed plus 4. Nah. Dude, this is so frustrating. Favorite physicist? Either Newton or Einstein, one of the basic ones. I mean, if you want someone more interesting, favorite physicist is gonna be me. That's my answer. Okay, I gotta get smarter at factoring this. 2 times m squared, 2m minus 7 times squared plus So to get this to 6, if I divided this by 7, I can't just do that. I'd have to subtract a certain amount. Maybe that's what we can do. Dude, I don't know how to factor this. Let's see what Wolfram Alpha has to say about factoring this. I know that's basically like the whole purpose of the problem is to get 2x plus 1 times x squared minus 4x plus 8. Okay, so I kind of see what they're going for. So right, all right. So let's try to get that. If we have the 2m basically, this is like dividing this by 3. And, oh my goodness. You basically just have to know that x squared minus 4x is a factor. X squared minus 4x plus 8. So this becomes m squared times 2m plus 1 times m squared minus 4m plus 8. So m's gonna equal 0 twice, then negative 1/2, then b square root 4 plus or minus the square root 4 plus minus the square root of 16 minus 4 times 8, which is 32, which is a negative 16, which is this will give me 4i. Two plus or minus 2i. So now we have we have, I've said that a lot, y equals c1 e to the 0 plus c2 x e to the 0 plus c3 e to the minus 1/2 x plus e to the 2x times c4 cosine of 2x plus c5 sine of 2x. So we just solved a 5th order differential equation. All right. All right, 24. Let's move on to undetermined coefficients. God, I hate these, but it's okay, we can do this. So this is where you do the... I'm gonna ask if we're gonna have... Checking 4.6. Exercise 10. What is, and then 4.5. What is 4.5? Not this. See you later. Undetermined coefficients, a useless method. The superior method, which is annihilator. I like annihilator. Alright. See what they have to say about annihilator. Oh, okay, not annihilator, but undetermined coefficients. I'm fine with annihilator. I mean, yeah, it's kind of lame, but also... Let's go to some problems. So that's just simply writing as a operator on y. I just realized if I do 2 more, I'll beat Black Pen Red Pen's record. But his differential equations were probably more interesting. Undetermined coefficients. Yuck. Oh. I just realized you do use undetermined coefficients. So this is the superposition approach where you do. So you still have to find the coefficients. But this is where you have polynomial superposition. So we don't have anything on superposition, but we do have annihilator. Okay. Alright, so I'm gonna work through an example. Alright, so here's an example. Y double prime, y prime, if okay, so step 1, solve the homogeneous DE. So YH, we have m squared plus 3m plus 2 equals 0. Is 4ac. I can factor that. What am I doing? M plus 2, m plus 1. So y homogeneous equals e to the c1 e to the minus x plus c2 e to the minus 2x. Alright, next we need to find a differential operator that eliminates everything. This will be a d cubed, and then we have the d squared that. Okay, d cubed times d squared plus d 3d equals 0. We have d equals 0 3 times. So now we know that y, our general solutions can have the form e to the minus x plus c2 e to the minus 3x 2x plus a plus bx plus cx squared. Okay, so now that is our y. That is our y. Yp particular solution. Yp particular, and so we can plug that into our. We're gonna have a system. So yp double prime equals b plus 2cx. Yp double prime equals 2c. So now let's plug that into the equation. 2c plus 3b plus 6cx plus 2a plus 2b plus 2c, or this is x plus 2cx squared, 4x squared. And then set up the system of equations. There's only one x squared term, so 2c equals 4. 2b plus 6c equals 0, and then 2c plus 2a plus 3b also equals 0. C equals 2, so that means b will equal minus 12 divided by 2 is minus 6. So now we have 4 is 2a minus 6. And also a equals 1. So now we just have y, our general solution, equals c1 e to the minus x plus c2 e to the minus 2x plus 2x squared minus 6x plus 1. Let's see if that's right. Okay, apparently a equals 7, and let's see why that is. Oh, this should be there's a 3, so this would be 18. So I was almost correct, but I just got a little carried away on the last thing. So note to self on test, don't go too fast. That's gonna, yeah, a is gonna equal 7. So all right. So annihilator of a sum is just a product of annihilators, and then annihilator of a product is you raise to a power. So yeah, I think, yeah, I can get used to these problems. I just need to do quite a few. Let's do quite a few of these. 25. After this, we will have beaten Black Pen Red Pen's marathon record. And we're not even through the halfway point. Well, actually, we're about there. Because we still got to do, still got to do lots of Laplace transform and series. Series is gonna take forever. I gotta get good at that. Alright, equals 8e to the 3x plus 4 sine x. So, if I remember my annihilators correctly, we're also gonna only have a one note card of formulas for the test. Since we only have one note card, I think I'll put down annihilators. Well, okay, see, I could just memorize them right now. In fact, I think I might do that. I just ate that. Yes, I did. Don't judge me. Don't judge me. Don't judge me. I know. Let's go ahead and look at the table. So let's memorize this table. So annihilator of t to the k, we know that. For a e to the rt, our annihilator is d minus r. For a cosh rt plus a b sinh rt, so d squared minus r squared. For A cos RT plus B sine RT equals D squared plus R squared. And then A e to the, is that a lambda t? Yeah. We'll just use MR. E to the mt cos RT plus B e to the mt sine, or is it the same mt? Yeah. Sine of RT. We use D minus, this reminds me a lot of Laplace transforms. D minus m squared plus R squared. So P of t e to the mt, we do oh, I'm guessing that's polynomial of t. So when multiplying a polynomial by anything, you just raise it times, you just raise it to the power. So polynomial times either e to the rt times f of t equals, well, you just do d of f of t to the pk, something like that. So let's just memorize them. Think about like Laplace transforms, right? Laplace of e to the at, or at is 1 over s minus a, so it's almost similar. Same thing with this one, 1 over s squared minus 1, or minus r, 1 over, well, it's not exactly that, but it's close, s squared plus, and then you have the 1 over s minus a squared plus 1. You either have s minus a or just 1. So it's similar to Laplace transforms, and since we're allowed to have Laplace transform formulas, then this will hopefully be easy. So our annihilator for this one is going to be d minus 3 times d squared plus 1. It's our annihilator. Solution of homogeneous is going to be m squared minus 3m 0. So our y particular, no, our y, so since that's going to be this part, so our y homogeneous is going to be c1 plus c2 e to the 3x, right? So now that we got that, we know that our y particular is going to be ax e to the 3x plus b sine x cos x plus c sine x. Yeah, And then our yp prime equals a e to the 3x plus 3a x e to the 3x minus b sine x plus c cos x. And then our yp double prime equals 3a to the 3x plus 3a e to the 3x plus 9ax e to the 3x minus b cos x minus c sine x. So we have 6a e to the 3x plus 9a x e to the 3x Alright, so then we do minus b cos x minus c sine x minus 3 times our y prime. So 3a e to the 3x minus 9a x e to the 3x plus 3b sine x plus or minus 3 c cos x. That equals 8 e to the 3x plus 4 sine x. Now we set up our equations. That and that cancel. We have 3a equals 8. Then we have cos x terms. Cos. Negative 3 minus 3c minus b equals 0, and then c, or sine terms, are 3b plus c, or no, minus c, hold on, 3b minus c equals 0. You have to multiply either one of these by 3. No, the sine one's gonna equal 4. So multiply this top one by 3. We get and then So we have 6 fit, b equals 6 fifths. Equals 6 fifths, yeah. Now we have our final equation. Yes, thank you. Lunchtime. That is huge, but thank you. Thank you, thank you, thank you. We do need bread. So next time you go shopping. Alright. Alright, so y equals, just plug everything in. C1 e to the, or C1 plus C2 e to the 3x plus 8 thirds x e to the 3x plus 6 fifths cos x minus 2 fifths sine x. And let's see if this is right. Yes! Okay, I think I'm getting good at these. And I have just beaten Black Pen Red Pen's record. And I can go ahead and tell Black Pen Red Pen. Yeah, the camera's not facing me. Can't see that, yeah. Alright, I think we can take a short break, but not that long. I gotta get going to the next section, which is variation of parameters. We'll do another one of these annihilators. We still gotta do annihilators and word problems. Word problems, annihilators. Now, I think we're good on those, but, you know, just in case. Alright, variation of parameters. We have always messed these up. Or I have. So, we're gonna just do this next one step by step. No, I've already done that one before. This one should be a little bit quicker. For y double prime 36y equals cosec 3x. I'm gonna have to write a bit smaller for these now because this is gonna be a lot. So our y homogeneous solution is we have 4m squared plus 36, m equals plus minus 3. So we have yeah, what is it? Cos the C1 cos C1 cos 3x plus C2 sine 3x. Alright. What is this? Oh, that's right, we don't use the homogeneous solution. What am I thinking? Right? Oh no, we do. Yeah, we do. Oh, it's plus minus 3i. And so since we divided everything by 4, our f of x equals 1/4 cosec 3x. Let me go ahead and start eating now. I don't think anyone wants to see me eat, so you can face that way. I'm going to have to get off at sometime around 2 o'clock my time, which is in about an hour or so. And so this won't be my main world record attempt. Most differential equations done in one tank, but it'll still beat black and red pens. And I'll get back to streaming later today. The dog wants my Chick-fil-A. I don't blame him.
Let's sing a song full of hope, full of pain. Why don't you sing along, my friend? For it's our last refrain. Forever young, ever strong, ever brave. Memories like this never end. No, they don't fade away. So when I'm gone, I'll be right there, close to the sun. Keep holding on, and I'll be right there, close to the sun, close to the sun. Close to the sun.
So I could memorize the whole Wronski and 1, Wronski and 2, Wronski and 3. Basically Kramer's rule. Okay. So we got that determinant. And you know that u1 prime equals so yeah, this is basically just Kramer's rule. It's Kramer's rule. So alright. I just realized it's not facing me, but it's because I'm eating. And I don't think anyone really cares. Alright, I'm back. Alright, let's get to work on this problem. We got cos 3x sine 3x, negative 3 sine 3x, and then 3 cos 3x. Gonna be 3 cos squared plus 3 sine squared, which is just gonna be 3. Now we know that u1 prime equals negative y2, which is sine 3x times cosec our f of x, which is 1/4 cosec 3x. This cancels. This is negative 112. Okay. Alright. So, negative 112. Now we know u2 prime equals negative y2 wait, that was u1. u2 is just y1 cos 3x times it's cosec 3x. So, yeah. u1 just simply equals negative 1/12 x, and u2 equals the integral of 1/12 of cotan 3x, which is cos over sine, which is ln sine, and then 1/3, so this is 1/36 ln sine 3x. Now we have our final answer of y equals c1 cos 3x plus c2 sine 3x minus 1/12 x cos 3x plus 1/36 ln sine 3x times sine 3x. Let's see if that was right. Yep, we were correct. Let's go ahead and do a couple more problems, like with this. I think I finally get it. So we have, thanks to the Wronskian, right? So 27. U1 prime equals negative y2 f of x all over w, and then u2 prime, let's write this smaller. I'm gonna have this on my formula sheet. Equals negative y2 f of x all over w, u1 or u2 prime equals y1 f of x all over w, and our w equals the determinant of y1, y2, y1 prime, y2 prime. Let's write that a little smaller. So those are some basic ones. Let's get some more interesting. Okay, that one took forever. I don't want to do that one again. Oh, this one's cool. I don't think I've done it before too. Y double prime plus 3 y prime plus 2y equals sine of e to the x. Okay. So for our homogeneous, we have m plus 1 times plus 2 equals 0. So negative 1, or I don't think order should matter, so now we know that y alright, and then plus the w no, what am I doing? So that means our y1 equals e to the minus x, y2 e minus 2x prime equals negative e to the minus x, and y are not. And then our f, of course, equals and w equals negative 2 e to the negative x minus, so plus e to the negative 3x. Oh wait, no, that's negative 3x. Yeah. E to negative 3x plus e to the 3x equals negative e to the minus 3x. Right. So now we know that u1 prime equals negative y2, which is negative e to the minus 2x times f of x, which is sine of e to the x, times the Wronskian, which is going to be times negative e to the negative 3x, or to the 3x since I brought it up from the denominator. So equals just simplifying e to the x sine of e to the x, and that's going to be easy to integrate. So u1 equals just sine of e to the x. U2 equals negative reason I'm not doing any initial value problems is that the Laplace transform does that easy, and like there's so many problems in here that would be so much like initial value problems that I could easily do with just Laplace transforms. So that's why I'm not doing them. I mean, it's probably good to, you know, solve it generally, then be able to plug stuff in. So let's go to what am I doing? I just had a rhythm and then I lost it, so it's gonna be a y1, yeah, y1, which is e to the minus x times f of x, which is sine of e to the x times divided by the Wronskian, e to the 3x, or negative. So this equals negative e to the 2x. So now we're going to have to integrate u2 Alright, oh, I just realized that this will be negative cosine. Yeah. So same thing with this one, this will be, alright. So this, u2. So now equals our c1 e to the minus x, c2 minus minus cos e to the x times u1, which is e to the 3x e to the minus x. Oh my goodness. Plus minus x okay, yeah. And then plus, what am I thinking? y2 times this, so minus e to the x, e to the minus x. Anything I can add together? These two are the same term, so this becomes so apparently these are supposed to cancel. I think I missed a sign somewhere. y2 I think I missed a sign somewhere, because one of these should have been a plus, and that cancels out, and this just becomes minus e to the minus 2x sine of the x. We're gonna do 3 more of these. All right, 28. All right, so solving the homogeneous, we've got equals well, we have m squared -1. I could have factored this. So dude, this sounds like Rickroll. This song actually sounds like Rickroll. Give you up, never gonna let you down. At least the lyrics do. Never gonna say goodbye. Never gonna turn around and desert you. Okay, so the Ronskins, we know our F is going to be ln(x). A Ronskin is going to equal, we have e to the x, so negative 2 e to the minus x minus e to the minus x equals e to the minus x. Very simple. So now we do u1 prime equals negative y1 negative y2 what was it? It was y2 100%. Yeah, y2 over y2 f of x, so y2 f of x e to the minus 2x ln x all over all over e to the Ronskin, which is just times e to the, or times negative 3 e to the x. It's not a row, that's e. So equals 3 e to the minus x ln x. How do we integrate that? So u1 equals oh, I see. think we're supposed to be using special functions for this one. So yeah, this is gonna equal 3 e to the minus x ln x minus or plus yeah. So we do negative. I'm guessing that's like ei of negative x or negative ei of x. Oh, it's ei of negative x equals negative. Yeah, this is ei of negative x. Oh, it's almost ei, except that's ei isn't indefinite. Oh, let's see what the answer looks like. Oh, it doesn't even, it just leaves it as integral defined. It doesn't even bother integrating, so that's kind of lame. You know what, we're gonna make number 2 a different one. That was like really lame. There we go. Found what I needed. So yeah. So I do cofactors. 1 times that, 0 times that. So 1 times 1 times this determinant, which is sine squared x plus cos squared x. And the other two are 0, so Wronskian is 1 of x equals tan x. So now we have all we need. Our W1 Yep, I just ate my. Yep, I just did that. Because I am so focused. I was so focused on what I was doing. Yep. Alright, so we have the U1, U2, U3 prime. U1, U2, U3, right? So we have the system U1 prime plus U2 prime cos x plus U3 prime sine x equals 0. That is 0. U2 prime So let's see if I can get this right though. If we have Ron's determinant of U1 prime is the determinant of all this junk, except its column is replaced with 0, 0, tan x. Then we have cos x, negative sine x, negative cosine x. Then we have sine x, cosine x, sine x. Determinants u1 prime equals tan x times this determinant. So I'm using cofactors, which is cos squared plus sine squared, which is 1. So that's easy. U 1 equals ln sec, right? It's a sine over cos, so yeah, ln sec. Alright, now I don't think the others will be super easy. U2 prime, since the Wronskian's 1, we don't have to worry about the bottom. It's going to be 1, 0, 0, 0, 0, tan x, sine x, cos x, negative sine x. It's going to equal tan x cos x, which equals sine x. So, or negative sine x, so u2 equals cos x. So now we finally have our answer to this third order differential equation is c1 plus c2 cos x plus c3 sine x plus u1 is tan x u2 is cos x cos squared x plus sine squared x minus sine times sine x times ln of sec x plus tan x. That reduces to 1. 1 plus c is another c, so this is y equals, I mean, I guess it's still C1, but C1 plus C2 ln cos x. What happened? Integral of where's the ln cos x? Oh, right there. The u1 is not tan x. It's ln cos x. Yeah. That's how we got it. Or ln sec x. There we go. And plus 1, that goes away. So this will be plus ln, or minus sine x times ln of sec x plus tan x. That took a while, didn't it? Which class am I graduating? More than likely 2022. I could graduate next year, but it's not looking like that from, you know, what situation and the classes I'd have to also finish. So I'm gonna graduate with 2022. From high school, not from college. College is still a wild card because I could get very far ahead and maybe graduate college in... What college do I plan on going to? Probably MIT, Princeton. If all that fails, then maybe like a state school. But I think I've got a pretty good chance at getting into those schools. The only other problem though would be money. I have no clue how much those are going to be other than expensive. So I have to make sure it's worth it. Okay. I think we are good on variation of parameters. Like, no, didn't I say we do 3 more? Okay, that's fine. Do 3 more. There's just not enough good ones here. I guess we could do, I don't want to look at the answer. Was that 28 or 29? Oh my goodness, I can't see. That's not fair. 28. Okay, so we're on 29. Nah, I don't do, yeah, we're on 29. Cal 2? It's definitely harder than Cal 1, but it's not like impossible. I just think that you have to learn to focus more on like what's being taught, cause it's not as easy to see things anymore. It's not like as concrete. Like you have to think a little bit with the problems, both with integration and with series. So my advice would be make sure first off you are super comfortable with algebra, like and manipulating stuff, because that's like most of what you're doing is you're algebraically like manipulating things to make it nice. So like if you're not super comfortable with algebra, you're gonna have a really tough time, because that's like almost half the class is just using algebra to make your calculus much simpler. And then other things in Cal 2 would be I mean, I have no clue what your school is like, but I would just say make sure you're reviewing problems because it's very easy to forget, like all the little things. Like I know I've forgotten a lot about like sequences and stuff because I didn't really care. And technically they probably don't matter too much until maybe like analysis. So, but to get through the class, you're gonna still have to make sure you learn on that. All right. Do I do math competitions? Um, no, I do not. I can see why people, like to do them. They're pretty fun. I just personally don't have. First off, I don't have a way of being on a team. I mean, I know I can still do the MC solo, so I'll explain that in a little bit. I don't have a team because I'm sort of just on my own. And also, I don't I'm not with like a school and stuff. I don't have mentors. Well, I do technically have a mentor who can teach me that stuff. Um, I think yeah, if I was working on that stuff, I'd probably be doing pretty well. But I'd say here's the second reason is that I just don't find the math that interesting. Like it's fun but not interesting if that makes any sense. Um, that's what I'd say 'cause I mean, uh you have to think, and that's the fun part is when you finally actually come up with the answer. Oh, and a third reason is that I do not do well in high stress environments. I do horrible in high stress environments. I don't think I'd get too stressed though if I was if I was just not tryharding. But if I was taking it seriously, then I'd get super stressed if I was taking that like super seriously, which I know some people do. I do occasionally check out those problems time to time. Yeah, I mean the concepts itself are simple, but I think the cool part about them is that they're still challenging, like really challenging. Like I could pull up an IMO problem right now and I'd probably have a hard time figuring out what to do. Let's see. Okay, that's not I googled IMO problems and I get the hard ones. Let's look at just a regular one, not like one of the famous hard ones. I don't want to download all of them. Okay, whatever. Oh shoot, I just downloaded it. No, let's do a PDF of this random one. So yeah, they've got algebra, combinatorics, geometry, and number theory. I'm like okay at combinatorics, I'm okay at number theory, pretty good at algebra, and I'm horrible at geometry. Or at least like at a high level. So prove that inequality, no thank you. Ooh. Oh jeez, okay. I hate inequality type questions, but they're kind of true. Or not true, they're kind of good. Oh, here's a cool question. Nope. Let's try to go. I think the thing about these geometry questions that makes me really horrible at them is that I can't see the extra thing that I need. Like I don't know what I need in a geometry question. In a calculus question, I see that I need something and then I can get it. but like in a geometry question, it is like not obvious at all what you need, at least for me. I know there are some people who are really good at figuring out, okay, I need like this kind of circle with this kind of triangle embedded or inscribed. And you know, people are very good at doing that. I just personally am horrible at like visualizing what shape I need. Which might be tough if I do any topology, but I don't think topology is going to be like that. Topology is more like actual math. Like that kind of geometry is like sort of just you know what? I don't know. I'll figure it out later. All right, here's a problem. Y double prime plus oh my goodness. 2y prime plus y equals e to the minus t ln t competition chemistry. I wonder what that's like. Do y'all do problems or do y'all do experiments? I can keep up this because I can let's solve this. Okay. Yeah, I found chemistry really fun. I just wasn't good at it. That's the problem. I mean, that's the same thing with this class, is I found it pretty fun, but I'm not super good at it. We go ahead and do, oh yeah, so then we have our m squared. Multiple choice part 1, free response part 2, and lab part 3. So I'm guessing for the multiple choice, they just sort of ask you like simple reaction or type questions. But then for like the free response, they ask, because I'm kind of wondering, how do they make chemistry like really hard? I'm guessing in the lab part is where it gets actually hard in free response. But like, what kind of questions do they do on the multiple choice? Oh, you'll do OChem and quantum chemistry. Okay. I found electrochemistry really fun. But organic, I haven't done organic chemistry. Yeah, I've heard organic chemistry is hard. And I kind of want to take that in high school, but I could also wait. I just don't have to, I could just not take it at all. Depends on what I want to do for my senior year, because there's a lot of other things I want to do. So I might not have time for organic chemistry, especially if I don't really need it. Then but I do remember that I found organic chemistry, like the stuff we did in Chem 2, was really fun.
Getting stronger every day. Keep on pushing through the pain. Keep on running till we die. Ain't no mercy in this life. There's nowhere left to run away. No, there's nowhere left to run away, run away, run away, run away,
So here's the thing about DiffyQ, is that you could technically understand most of the process as like a pre-cal student. The only thing you might not understand would be like, okay, maybe not. Actually, I don't know. Cause like, there's just a lot of algebra going on, but there's also some calculus. Like this right here, when I went from here to here, I just did some calculus too in my head. So maybe that's why you don't know what's going on, because I'm like not showing all my steps. But like right now, I'm doing the determinants of a matrix in my head, and you might remember determinants from pre-cal. Or this right here was just solving a polynomial, and I what's it called? Solved it in my head. But you could either use quadratic formula or you could factor it, and you could solve that for the m, and then you just plug that into a formula like this. Alright. It is pretty hard though, like, you know, I'm not doing too good in the class. I've got to do good on this final. What am I doing? This is so, yeah, and right now I'm just doing Kramer's rule, but in my head. Do you remember Kramer's rule from pre-cal? Yeah, I'm just doing that, but in my head, because we're solving a system that looks like this. And then you. So we're doing Kramer's rule, but there's like a nice formula to solve this, and that's what I'm doing in my head. This is gonna be, I realized I just did that wrong. That's gonna be negative x minus x ln x all over 2x, and then minus 2x, and then yeah, so this and that cancel. So u1 equals integral equals there we go. So that was some calculus 2 stuff. And I'm majoring in math. I'll probably get a major. Yeah. Probably get a major in physics too. U2 prime. U2 prime is gonna be, just the y1, which is minus x e to the minus x minus it's minus 3/4. That is positive 1/2.
Come and fly away with me. Come and fly away with me. Come and fly away with me.
Here we go. That's the answer. All right. I think we're good on variation of parameters. Good on variation of parameters. We are now on problem 30. Let's go to Cauchy-Euler. We'll do 3 of these.
Somewhere by the emerald sea, where the moon and water meet. Somewhere close to harmony, when the world is sound asleep. Something's gonna bring the change, journeys we are meant to take. Something at the edge of space, calling us to fly away. Don't you be afraid, everything will change. You and I, jumping off the edge. They say dreamers never die, so come and fly, come and fly, come and fly away with me.
So I'm gonna write down Cauchy-Euler. So for distinct real roots, it's y equals c1x to the m. It's going to be y equals c1 x to the m1 plus c2 x to the m2. And then for repeated real, it's going to be y equals c1 x to the m1 plus c2 x to the m1 ln x. And then for complex roots, it's going to be y equals x to the a times c1 cosine of beta, or x to the alpha beta ln x plus c2 sine beta ln x. Then you can do the whole variation of parameters, changing to constant. Let's do a simple Cauchy-Euler. Okay, that wasn't too hard. I am starting to slow down and get a little tired. But yeah, I forgot how easy these were. Yeah, that's kind of boring. That one has an answer though. Let's do this interesting one. Alright, so we have
Greetings chosen, I've been waiting here for you since the beginning of this universe. You know the world is fading. There's a secret power hidden in your
minus minus. 6m minus 6m minus 12m. When's my final? He gave us 4 days to take it. So like he gave us 4 days we could take it on, and I'm choosing, depending on how comfortable I feel today, I could either take it tomorrow or Thursday morning. Tomorrow night or Thursday morning. I'm thinking Thursday morning, but at the same time, you know, it really depends. Show what we are. Alright, so what we have done? We've done 2 Cauchy Euler. Let's do one more. I mean, that one was plenty long, but oh, solve variation in parameters. This one, okay, yeah. We had this on our test last time, so we're gonna do it. Alright, x squared. So for YH, we have m squared plus m minus m. Oh, that's rough. Dude. Yeah, I dislike it when teachers are hard for seemingly no reason. Like, I guess that there is a time and place to be tough, but I feel like, you know, if you can tell your class is struggling, the last thing they need is to you just give them a hard test. just for the sake of, oh, you know, you need a hard test. I mean, I'd say, I mean, if your class is bad, don't give them a super easy test. Otherwise, that'll just be kind of pointless, you know. But at the same time, I also think that your tests should match your homework, right? If you give super easy homework and then super hard tests, that's just not good professing. Or good teaching, I guess, but yeah. So I'd
Summer in the hills, those hazy days I do remember. We were running still, had the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms. This is home where
so I
we
was checking or not to see if this was the golden ratio, and it's not. It's off by a little bit.
I still hear you in the breeze.
Just kind of sad, but it's whatever. Who cares? So now, oh my goodness, this is gonna be really ugly. Um, like, could it have been? Oh wait, no. I realized, no, it wasn't that. Y equals x to the m, right? My brain turned off for a second, and y prime equals m x to the m. Y double prime equals m squared minus m. Then we're gonna have m squared minus m plus m minus 1 equals 0. M equals plus or minus 1. Oh, okay, so it's gonna be y c1x plus c2x minus 1. y1 equals y1 equals x, y2 equals x to the minus 1, y1 prime equals 1, y2 prime equals negative x to 2. Wronskian equals negative x to the minus 1 minus x to the minus 1 equals 2x to the minus 1. Alright, then our it's more of a homeschool kind of thing, although I take classes at a college. But, you know, everything's at home now, so it might as well be consider myself homeschooled. But yes, I do not go to a normal public high school, or I don't go to a private high school. Alright, so we got that. So now we just got u1 prime equals negative y2, which is x to minus 1 f of x all over Please tell me that's right. Okay, so there's some simplifying we can do. First off, this should be an x cubed. Okay. I see where everything went wrong. This should be plus integral of 1/4 x squared man, I don't get how everything cancels out. Maybe I forgot a 2 somewhere. Yeah, but everything's supposed to cancel out, and we get so I need to work on that one. I need to make sure I get that one right because so variation parameters plus Cauchy-Euler, like combined in the same problem, is what I need to work on. Okay. So everyone at your school's trying to get into a top college. Do you think they can actually do it? Like, I guess, I mean, if you try hard, you probably can get into a top college, but I guess it is kind of lame spending your entire high school career just to try to get into college. Like, I mean, like, yeah, I'm trying to get into college. Like, that's not my only goal of high school. Like, that's not the reason I'm doing differential equations as a sophomore. Oh, Green's functions. I need to learn about that. Thankfully, that's not on the exam. Yeah, I don't have to worry about Green's functions for now because that's not in the exam. Thank goodness. All right. I think we can close the book on higher order equations and move on to series. God, man, I love series. Just kidding, you know. Before anything, I'm gonna need to use the restroom. So like, you know, they're the type of people that would and do 15 AP classes even though they don't really care too much for world history. Like that's the reason I don't need to do world history, so I'm not going to. Even though it probably would look good on my application to I mean, it might look good. Same thing with sports, you know, I mean, I do play basketball. I don't think it's as big enough in my life though in order to put it on my application just because that's not what I'm interested in. Like, I mean, I will put like that I do piano and that I do percussion, and that I might also mention my gaming on there. How I started a short-term gaming team organization. It wasn't that amazing though, but still, like, you know, I'm on my application. I will make myself look good, but I'm just gonna talk about the things I actually liked doing. I mean, I liked playing games. You're solving geometry questions? Well, I mean, let's see. We've got these two chords, and then we've got this tangent, and we're trying to find that angle. Yeah, I know that looks like chicken scratch. What's an interesting geometry question? If we have a circle, radius r, and a triangle who is tangent yeah, whatever. I am from Yeehaw Land, USA, where we ride horses and make lots of barbecue. So I currently do not know if we're going to be having series questions on our tests. I super hope that we don't, because that is the absolute worst section of differential equations, is series solutions to differential equations. I mean, it doesn't hurt to work on it. Okay. I know you just put me on the live TV, but I really need to use the restroom, and I need to what's it called? I need to throw this away. So I will be back in about 2 minutes. Okay. Alright, so see if I can do this without any help. I'm gonna have to write really small. Okay, I'm gonna have to look up a little bit of how to solve these because I seriously just have such a hard time following along. Hold on. So I'm gonna do a similar problem. Nothing changes except this sign right here. So we can set that this is equal to 0. So we can now set that AK the aeronautical tip.
We're gonna go to the moon. We're gonna have a base on the moon. We're gonna send people to Mars, and make life multiplanetary. And I think this day heralds a new age of space exploration.
Okay, so So now we have our table, our k values. And we have our ck plus 2 equals ck minus 1 all over so at 1 we have c3 at k equals 1 c3 equals c0 all over 3 times 2 times 1. Okay. I guess C and A are the same thing. I'm just switching to the notation the book uses. Yeah. So every third term is 0. So guessing that it goes C0 plus C1 x plus C2 x squared, which is 0, plus 10. Eight, 9, 10. I don't think this part is completely correct, but it could be the 3n factorial. But hey, I think we did pretty good. Oh man. No, yeah, okay, there were certain things that are missing, so this part isn't correct. It's C0 times some series. We have it here, basically. And it's... So apparently the, Oh, and they leave out the first couple terms. Yeah, I forgot about that, these terms right here. So, our actual answer...
When you feel it's hopeless, when you think that you lost, oh, I will take your hand and we'll rise up from the dust. Oh, here we go, go, go.
So yeah, we have y equals
We're unstoppable. Don't be afraid to show what we're going for. This is what we know.
c1 times 1 plus
Everybody's gonna see it. Oh, all you need to know is that we're holding on. Even
of
if
x to the
we
3k.
rise up
I was almost there.
and we believe
Over the...
we're not gonna stop until we reach it. Oh, all you need
That
to
is
know
3k factorial.
we rise up from
That is 3k factorial. So I was right.
rise up from the dust and claim our throne. We all have our reasons why we are on this track. Oh,
Hold up.
we all have our burdens, yeah, but we just keep on fighting and we never look back. Here we go, 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 let us heal and grow. You won't be alone, we're unstoppable. Don't be afraid to
We have 3 times...
this is what we know.
It's missing every multiple of...
Still breathing, standing up, everybody's gonna see it. Oh, all you need to know is that we're holding
I wish it had a better series. But basically, yeah, it's like a product. I equals like, I don't know, 1 to k of like 3i plus 3i minus 1 and then 3i plus 1. So it's something like that. It's not exactly factorials. But yeah, we solved the IREA equation. So we're gonna solve one more series question, then we'll move on to Laplace transforms, because I am so sick of these series questions, but I have to get good at them.
And silent, calm before the storm. Gold and diamond, jewels behind the throne. Into the night, out of the dark, take to the sky, chasing the stars. All that we say,
So this is
all that we are, waiting to fly. This is the start. Hide inside
Okay, that was really lame. These series questions are so lame. Like, I'll do a couple later after after I get off for today. But for now, we need to move on because we get the point, you know. How to solve a series. First off, you substitute the sum that your power series, Cn x to the n, and your derivatives and stuff. Find 1, 2. Then you find a recursion formula. Oh, actually no. Before you do that, after you substitute, you're gonna want to change powers. Then step 3, change index. So make it like one big series. Then 4, you then you find recursion formula. Then step 5, make table of values. 6, make linear combination and plug in values. Something like that. So we're still on 33. But we're gonna now move on to Laplace transform. Oh, transform of a periodic function. Oh, I guess I didn't know this. I don't think we need to know this. The Laplace transform of f of t equals 1 over minus e to the s t, where t is the period, t of e to the minus s t f of t. That makes a lot of sense, because you know a function that's non-periodic has t equals infinity, and so we have 1 over 1 equals 0 to infinity of e to the minus t f of t dt, which is equals the Laplace f of t. So I guess you could call that the full definition of the Laplace transform, equals the 1 over 1 minus e to the negative st times the integral from 0 to t of e to the minus st of f of t dt. But that's not what I'm looking for. I'm looking for solving initial value problems. Oh, these are some challenge problems. I don't need that. So I think I know what we're looking for, just 7.2. Solving IVPs. So So 5 ways. We're gonna do 33. We're gonna do this differential equation 5 ways. One way, first way is gonna be just a simple guess and check. That was step 1, was just to guess and check, intuitive. Step 2 was by separation of variables. You do 1 over y dy equals dx. Then you do integrate both sides and you get ln y equals x plus c. Y equals c dx. Then step 3, using integrating factors, so this is dy dx minus y equals 0. So then our mu of x equals e to the minus x. Now we have e to the minus x to y equals 0. Integrate, and then we have y. So now we have e to the minus x y equals c. So y equals c e to the x. That was the third way. The fourth way is using series. So we have, this is going to be the sum n times cn. I just realized my music ended.
Getting stronger every day. Keep on pushing through the pain. Keep on running till we take. Ain't no mercy in this life. There's nowhere left to run away.
So we did that series. Now the fifth way to do it. I guess there's a sixth way to do it, or fifth way to do it would be, is gonna be dy minus y dx equals 0. This is n, this is n. Yeah, you could do it that way. We're just gonna do Laplace transform. You take the Laplace transform of both sides. You get s y of s minus y of 0 equals y of s. Now we have s minus 1 y of s equals y of 0. So y of s equals y of 0 times 1 over s minus 1. Take the inverse Laplace of this, and you get that y of t equals y of 0 e to the t. So, yeah, it works. How long have I been live? Almost 6 hours? Wow. I mean, we covered most of the course. If I do this again tomorrow, I will 100% be ready with for the test. So let's go ahead and do some problems. I think we can go to 40. I have to get off at like 4 something. Plus now we take the Laplace transform, we have s squared minus s y of 0, which is y of 0, which is y prime of 0 plus y of s, right, equals Laplace transform of sine is just root 2 over 2. So we have, it's a b over, so times root 2, all over s squared plus b squared, which is 2. So this is just 2. Now we have and this is 0. Oh wait, y prime of 10. No, it's y prime of 0 equals 0.
Let's sing a song full of hope, full of pain. Why don't you sing along, my friend? For it's our last refrain. Forever young, ever strong, ever brave. Memories like this never end. No, they don't fade away. So when I'm gone, oh, when I'm gone, I'll be right there, close to the sun. Keep holding on, keep holding on. And I'll be right there,
forgot how long Laplace transform questions were. Yeah, if we can get to like 40, that'd be amazing, but I have no clue if I'll be able to do that in time at least. We'll wait on that question and then we'll do that one. Let's check our answer real quick. Yes, we got it right. Alright, so next one.
Greetings chosen, I've been waiting here for you since the beginning of this universe. You know the world is fading. There's a secret power hidden in your soul. Don't be afraid to use it. There are voices in your head saying that you're a failure. You're not good enough, but you know that's not true. There is a secret power hidden in your soul. Don't be afraid to use it, 'cause you're the one.
Okay. Now we take the we get s y of s. Oh, we need our initial value, which is 0 equals 0. That's always nice. Minus 0 plus y of s. What is it? Since it's cos, so it's s plus 3 all over s plus 3 all squared plus 4. Now we have y of s equals
Infinite power.
good. Hello. Purple on top. We have just hit the 6-hour mark, and we are doing Laplace transforms. Like I said, or maybe I didn't say this, but I'm only studying the stuff that's going to be on the exam. That's why there's not lots of stuff here, because there's not going to be a ton of stuff on the exam. Hello, Mike Oke-sama. Yes, I know what that name is. So, like, that's why you're not gonna be seeing too much of, like, Dirac delta or unit step function problems. Yeah, it is. Hello, purple on top. How are you doing? We're currently doing Laplace transforms. I'm gonna try to get to 40 problems before I have to go. And I think that'll be a good place to stop. And I'm probably gonna stream tomorrow because there's definitely more problems I could get used to. But this was just more of a warm-up to see, to gauge what do I need to work on. I think most of the stuff from the earlier chapters I'm pretty solid on, but some of the later stuff I'm not so good at. So now we do A plus C equals 0, 6C plus A plus B, and then B plus 13. We have, let's do A plus B minus 6A equals 1, and then B minus 13 equals 0. So now we got B minus 5A, then equals 1, and B minus 13A equals 0. So make this plus, now we got 8A equals 1A, 1/8, and then C equals negative 1/8. Then now we have 13A negative 8, so B 13 over 8. So now this equals of
In the hills, those hazy days I do remember. We were
S
still, had the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand.
What tablet am I using? It's let's see, brand is X Pen. Specific name artist 15.6. What? Model artist 15.6. So X set. That's or X Pen artist 15.6. Yeah, or 156. That's what I'm getting. So we're gonna have one. Hello, Purpleowit. Bullet. So if we do that, next thing we will need to do is subtract 10. So it'll be minus 1a times 10 all over, or add 10, and then we do there we go, then plus that whatever that last portion is, which is actually minus 1/8 times 1 over s minus 1. Yes, that is correct. Okay, so this is actually the inverse Laplace. 1/8 s plus 3 all over plus 3 all squared plus 4 plus... What time is that at? Okay, so this will be my last problem. So y'all are here to witness my last problem. It's my last problem, and I'm gonna have to go after this. So couldn't get to 40, but 35 is a nice number. So let's see, that's gonna be e to the negative 3 t cos 2t plus 1/8 plus 10/8. Oh, hold up, I didn't finish that. So this is 2. We need a 2 up here, so we get 5. So 5/8 e to the minus 3t sine 2t minus 1/8 e to the negative t. And that's it. Thank you guys for watching. So I think I did a pretty decent review of differential equations. We did 35 different differential equations over the span of about 6 and a quarter hours. So I thank y'all for joining, and yeah, I'll see y'all later. Peace.